Greetings. This week we are talking about grade 8, specifically the geometry standards. Students need to understand congruence, similarity using physical models, transparencies, or geometry software, understand and apply the Pythagorean Theorem, and solve real-world and mathematical problems involving volume of cylinders, cones, and spheres. Find a way to partition a regular hexagon into two congruent figures. Explain how you know the two figures are congruent. So if we start with a regular hexagon here, there are multiple different ways that I could split it into two congruent figures. Particularly, I could split it as I have pictured, or split it in any other one of the vertexes. We could draw a line through opposite vertices to divide the hexagon into two congruent pieces. Each side results in a trapezoid, and if we were to make a reflection across the line that we drew, the line takes one trapezoid to the other. Find as many ways to partition a regular hexagon into two congruent figures. So here's one option, just slightly off-skewed, and we could rotate this and continue the same type of pattern. Here's another one, and yet another one, and a final one. Note that there's an infinite possibility of ways that we could partition into two congruent figures. So in each case, the figures were constructed so that 180-degree rotation about the center will line them up one on top of the other. Find a way to partition a regular hexagon into four congruent figures and explain how you know the four figures are congruent. So let's say I take my hexagon and I cut it in four. And here I used isometric paper to do that, and then I colored them. If we consider the vertical and horizontal lines as the lines of reflection, the yellow region is the image of the red region when we reflect across the vertical line. So these two red regions are congruent. The green region is the image of the blue region when we reflect across the vertical line. So those two regions are congruent. Further, the yellow region is the image of the green region when we reflect across the horizontal line. So those two are congruent. And so all four regions are congruent to one another. Find a way to partition a regular hexagon into 8 congruent figures. How do you know the figures are congruent? So here I've partitioned using the same isometric paper into 8 different trapezoids. We can show they are congruent. Let's start with the vertical line. That kind of splits it down the middle here. All four regions on the left of that vertical line are congruent to their mirror images on the right. We can show that the purple and orange regions are congruent if we were to draw another vertical line directly down the left side here. We could show that these two are congruent if they reflect across that line. Further, if we were going to rotate a multiple of 60 degrees around the center piece here, all 8 regions would also be congruent to one another. Part of your homework then is to find a different way than we did in the lesson to partition a regular hexagon into 8 congruent figures. Find a different way than we did in the lesson to partition a regular hexagon into 4 congruent figures. Then find yet another way to partition a regular hexagon into 8 congruent figures. You might find it helpful to use isometric graph paper, which is provided in the discussion. When you found your solutions, scan and upload them to the regular Hexagon discussion board. Comment on at least one classmate's strategies. Translations slide objects, rotations turn objects, and reflections flip objects. Image A and image B are both rotations of the pre-image 1, yet they look different. How can we describe the rotations? Let's start with going from the pre-image 1 to image B. I see that if I were to tip my pre-image clockwise, I would be able to describe the direction. Further, if I were to tip my pre-image counterclockwise, I would be able to describe the direction to image A. I can also say that the degree of my rotation was 90 degrees. So ultimately, we had a 90 degrees clockwise rotation to obtain image B, and we had a 90-degree counterclockwise rotation to obtain image A. We can also describe reflections, but first we need a reflection line. So let's start with line 1. I can see that if I were to reflect over line 1, I would obtain object C prime. Further, if I were to create another line for a reflection, let's call that line 2, I can flip from C prime to C prime prime and reflect over that as well. So we had a vertical flip from image C to image C prime, and we had a horizontal flip from C prime to C prime prime. The arrow below is rotated 90 degrees counterclockwise. Draw the image of the arrow after the rotation. Pause the video and see if we can do that. Your image should look like this one, rotated 90 degrees counterclockwise. Transformations preserve side length and angle measurements. Describe the transformation and fill in the missing labels. Which is the pre-image and which is the image? How do we know? The transformation is a horizontal reflection. So therefore, B and B prime are equivalent, C prime are equivalent, D prime, E prime, A prime are all equivalent. The pre-image is the blue shape, since the pink image is labeled with the prime notations. That is our indication that we have a new image based on our pre-image. Polygon ABCD is translated as shown. Which angle is congruent to angle B? Take a guess. Did you guess S? That is correct. Triangle DEF is rotated 180 degrees to form triangle HIJ. Which angle is congruent to F? Angle J is congruent to F. When figures are rotated, reflected, or translated, the images are congruent. Determine which images could be made by rotating, reflecting, or translating pre-image A. Pause the video and circle all those you think are correct. All the circled items can be created using translations, rotations, and reflections. They are congruent. Triangle DEF undergoes a vertical reflection. What is the length of ED? The length of E prime D prime should also be 4 millimeters. We know that it does not matter if it's rotated, reflected, or translated, images stay congruent. Which of the following transformation preserve congruence? Rotations, reflections, translations, all of the above, or none of the above? As I just stated in the previous slide, all rotations, reflections, and translations preserve congruence no matter which of the combinations above happen. Tell what is missing from each transformation's description. The green square translated right, but not up or down. The cupcake rotated 90 degrees about the origin. The blue plant was reflected in a slanted line. They're not very specific. The translation is missing the number of units the figure has shifted. So the green square was translated right, but it doesn't tell us how far right we need to go. The cupcake is rotated 90 degrees about the origin, but which direction was the rotation? Counterclockwise or clockwise? The blue plant was reflected in a slanted line. However, what specific diagonal line was the figure reflected over? It's not very specific. So we can't just say the obvious what had happened. We need to be specific with how it happens. Georgia made a painting in a coordinate plane. While it was still wet, she folded her paper along the y-axis, resulting in the image shown here. Then she folded it again along the x-axis, making a new image. What did her original painting look like? And what does the last image look like? When she folds the paper, they make reflections of the painting as follows with the dashed lines. With this, we see the orientations are reversed. However, the corresponding parts are the same distance from the lines in which they were reflected. We know the result of the transformation in the coordinate plane is always a figure congruent to the original. Jim drafted 2 copies of a logo in the coordinate plane. He wondered if the final logo was congruent to the first. Robbie said it wasn't, and Jim said it was. Who do you agree with, and explain? We know that if we have a series of transformations, we can prove 2 figures are congruent, just as if we had a single transformation. So let's say we rotate clockwise about the origin 90 degrees. So now we have lifted it this far. The image is still reversed, so let's try a reflection across the y-axis, which would make it look like this. So now it's the correct direction. However, one more transformation is needed to get us to the last image. We would need to go right 2 units and down 1 unit. The Pythagorean theorem is a squared plus b squared equals c squared. Take a moment to pause our video and watch the proof of the Pythagorean theorem using a hands-on method located within the same lesson videos.